Okay, section 5.5, the substitution rule. We can use the fundamental theorem of calculus as long as we have an antiderivative. But what if we have something like the integral of 2x times square root of 1 plus x squared dx? Then we don't have an antiderivative for this expression, right? And the idea is to change the variable from x to something else. And in the process, hope to simplify the function in the integral so that we can find an antiderivative, right? Okay, so let's do example 21. And in here, we actually do evaluate, the integral that we are struggling with, and given that from here we also noted, okay, noted that 1 plus x squared is derivative of that. The derivative of this will be equal to 2x. So we noted this. So we're gonna let u is gonna be equal to 1 plus x squared. So then du dx will be equal to 2x. Everyone know that, right? And then that can tell me du equal to, I multiply both sides by dx. I have 2x times dx. Okay. And then now I'm gonna go ahead and substitute the integral, become 2x multiplied by 1 plus x squared dx can be changed to be the integral of 2x. No, let me rearrange it, right? I'm gonna rearrange 1 plus x squared multiplied by 2x dx. See that? I just rearrange it, right? Because this can tell me this is du, right? And this actually can be square root of u. Right? So now instead of having an integral of u's, now I'm using the integral of x. So I have square root of, no, I say that instead of integral of x, now I change to be integral of u's. Square root of u's du, right? And that become I can rewrite u's square root of u become 1/2, u to the 1/2, and then du. And that can become u to the power 3/2 divided by 3/2. And I had to plus with a constant because this doesn't have any limit, so you need to plus a quick constant for the integral. Okay, so that become 2/3 because you divide it by 3/2, right? So it's just flip it, become 2/3, and then multiply by u to the power 3/2 plus c. And remember that we are using the x variable, so then our answer had to become back with the x variable. So I had to come back with 2/3 times with 1 plus x squared of 3 half, and then plus with a constant. And that should be the answer for this product. Also, use another color for support this answer. All right, so I'm done. And what's the key to using this relationship? We try it, see what happens. And if it doesn't work, try substituting a different part of the expression. So basically, to try, you have to try with, try some, some part first, and then see if it fits. If it doesn't, then you have to try another. So, for example, let's move to 22 over here. Maybe you want to think about substitute the x cube over here to become u, something like that. Or actually, for this one, you have no idea to split the multiplication of the integral, right? There's no probability for that. Also, you have no idea to take the entire derivative out of this product. So you have to think about substitution, right? However, you substitute which part you should substitute first. You might think about, okay, let's do x cubed to become u, right? So let's say if I think like I use let's use equal to x cubed, right? And then I have what du dx will be equal to 3x squared, right? And then you don't want to see any, you don't see any 3x squared term in the original function over here. So there's no way to get rid of this thing if you doing by this substitution. So you don't want to substitute u equal to x cubed anymore. So let's so for this case, we don't want to use x cubed at u. Okay. So another term that maybe we have to think about trying to substitute is x4 plus 2, right? Let's say I have u's equal to x4 plus 2. And if you take the derivative of that, let's say du dx, you will have what? 3x squared. Sorry, 3x cubed. Okay. 3x cubed. So so you can see, oh, there's a cube over here, right? There's a cube over here. X cube over here. Okay, so look like that will affect our substitution later. So what I do, I can either move the x to the other hand side, or I can just keep the x over here. I mean, I want to see if the x substitute, what is it going to be? I will have dx equal to u over 3x cubed. You can go by, move du equal to 3x cubed dx. And then you divide both sides by 3x cubed. We're going to give u dx equal to u divided by 3x cubed. Okay? Yeah, so same. Now what you do is I will substitute the x, and you will substitute the x4 plus 2, right? So let's substitute. u equal to x4 plus 2 and dx equal to du over 3x cubed. Okay. Then you're gonna have x cubed cosine u d come on, du over 3x cubed. Okay. And now you see that you can cancel something because all this is just product and so you can okay, so you can cancel this guy and this guy. Oh, you cannot cancel the 3, right? Cancel this. So now your integral become integral of cosine u du and over 3, right? I can move to the, maybe I'm gonna move 3 outside of the integral because the property with constant, right? So I can move out the 1/3 outside and have cosine u times u. Okay. Let me see. Oh, I made a mistake. Okay, I saw that. This number 3 should be 4, right? 4x cubed, sorry, yeah. 4x cubed. So then I have chain all number 4 here. 4, 4. And this is 4. Okay? So now you will have take integral of the cosine u. That's going to be easy one, and we give us it on 4 times sine of u plus c as a general, because this is a general integral, so you have to plus c, and then you have equal to come back with the x variable. You have 1/4 times sine of x4 plus 2 and plus c as the answer. Okay, so let me circle this. Right. Okay, so let's do example 23rd over here. For this one, I'm pretty sure that you must have to think about, substitution for the bottom. Okay, so what is that gonna be if I let u equal to 1 plus, oh, come on, man. 1 plus 3x squared, right? Then I have du will be, du dx will be 6x. Oh, there's no square here, sorry. 3x, this will be 3 only. Okay. So, if you multiply both sides by dx, you have du will be equal to 3dx. And then you have dx will be dx will be equal to du divided by 3. Okay, so now substitute. One is equal to 1 over u squared du over 3, the integral of that. And that's, I can move out 1/3. And now I have, use 1 over u squared can be divided as u to power -2 du. Excuse me. And now I have 1/3 time with u to power -1, because -2 plus 1, right? Over -1. Okay, and plus c. And that, if I want to simplify it, I have negative 1 over u plus c. Negative 1 over 3u plus c. And that can be back substituted as negative 1 over 3 times with 1 plus 3x. Plus c, okay? And that's going to be the answer for okay. Okay. Now here we have worksheet 7. So I will let you guys to work on this 2 worksheet later. Okay. Okay, so now okay, so here is a definite integral using substitution. There are 2 methods. Okay, let's do an example and see what we're gonna apply on that. So evaluate the integral from 0 to 4 of square root 2x plus 1 dx. So let's do method 1, use substitution, and then go back to the original variable. You can see down here is method number 2, which is use substitution and change the limit of integration. So So you can, so what does that mean? Uh, at like previous page, right? We have learned to do substitution with a general integral. We doesn't have the limit. So so in here with the example number 26, we have the integral with the limit. So um, so for that, we must we must think about you know when you do the solution, the limits should also change. Um, but we have two methods for here, and that the first one say do substitution first, and then go back to the original variable and do the limit. Okay, so so let's do the first method and see how to handle this one. So I have here, I will let u is equal to 2x plus 1. Okay. So then I have du dx will be 2. Right. So then I can have dx equal to du over 2. Okay, so now I'm gonna substitute. So I have integral from 0 to 4 square root 2x plus 1 dx will be equal to the integral from 0 to 4 square root u du over 2, and that's equal to 1/2 the integral from actually it's integral in here. Let me see. So so as I stated before, since you change change the variable x to u, so then the limits should also change. Okay, so in this case, I should not have 0 to 4 anymore. I should just gonna use limit from u1 to u2, something like that. Because for now I don't care about the limits of u, because later will come back with the variable of x. So I should just keep this one. I'm gonna have square root of u become u to power 1/2, and let's say 1/2 du. Okay, so apply the integral rule. I will have u to power 3/2. So 1/2 stay here, equal to divided by 3/2. With the limit from u1 to u2, right? I can simplify this one more time as 1/2 time with 2/3 multiplied by u to power 3/2. The limit is from u1 u2, right? And that could be cancel the 2 become 1/3 u3 half, and from u1 u2. So now because I will come, I'm gonna substitute back to the x. So then the interval will change back to 0 to 4. Okay, so substitute back. Let's say back. Okay, so I have 1/3, 1/3 x 2x plus 1. To half, and the interval come back with 0 to 4. So now I will just have 1/3 2 times 4 plus 1 3 half, and then maybe I have to add parentheses, and then minus for 2 times 0 plus 1 to the power 3 half, and then close parentheses. So then for this you will have 1/3 and multiplied by 9 to the power 3 half minus 1. Because this 1 to the power 3 half just 1, right? So I will have this can be become as 1/3 multiplied by, so 9 to the power 3 half will be equal to 27. Okay, 27 minus 1. And then finally you will get 26/3 as the answer. Okay, so that's the position. Okay, that is method number 1, as you see, right? Basically, I don't change the interval, change the limit. Now I will use substitution, and then I also change the limit of the integration. So again, I still have u equal to 2x plus 1, and then from above I have dx will be equal to du over 2. But remember that I know that the limit from 0 to 4, right? So I need to change the limit. So at x equal to 0, then I have say at x1 equal 0, then I have u1 will be equal to 2 times 0 plus 1. So 2 times 0 and plus 1. That's equal to 1. And then at 2 equal to 4. Then I will have u2 equal to 2 times 4 plus 1, which is equal to 9, right? So I will do the same like before, but at this step, at this step over here, okay, I will just gonna say 1/3 u to the power 3 half with interval from u1 u2. So u1 was 1, 2 was 9. So I just will just substitute into this interval. And that will be 1/3 times with 9 to the power 3 half and minus 1 to the power 3 half. And that will be the same answer as 26/3, as you see. Okay, so um, um, okay. So yeah, you can see that we have just finished 2 minutes. And now for exercise try number 24, anything else? No, okay. I will let you guys to in the class. Okay. See you later.